4.4, building functions from functions. We have some operations. F plus g of x is f of x plus g of x. F minus g of x is f of x minus g of x. F times g of x equals f of x times g of x, and f divided by g of x equals f of x divided by g of x. These are the same. They mean the same thing. So you can see them at any time. This is the way that we usually like to write it, but you can see it this way as well. Example 1, defining new functions algebraically. Let f of x equal x cubed and g of x equal the square root of x plus 1. Find the formulas for the function. We have f plus g. So f of x plus g of x. We have f of x minus g of x. F of x times g of x, and f of x divided by g of x, as well as gg. That would be g of x times g of x, gg. All right, f of x plus g of x. So we have x squared plus the square root of x plus 1. That's all that I can do with that. I can't add that any more together. I can only add square roots with square roots and squares with squares. So the next thing that we're going to do is we're going to take a look at the domain. Are there any problem areas? The square root is a problemed area because we can't have imaginary numbers. And so remember, you take whatever's under the square root and you set it greater than or equal to 0. The graph of a square root is the square root of x. We're setting it greater than or equal to 0. That's why. And when I solve for x, I get x has to be greater than or equal to -1. So we're going to say that the domain, we're going from -1 to infinity. Does that include -1? Yes, it does. Square bracket, -1 to infinity. F of x minus g of x is going to be x squared minus the square root of x plus 1. Again, if I was to solve, I would see that I'd have to be, the domain still has to be greater than -1. We're going from -1 to infinity. F of x times g of x, that will be x squared, and then multiplying by a square root, we can put it right next to it. Again, we're not seeing anything different. We're seeing that this is the issue, so the domain will still be from -1 to infinity. F of x divided by the square root of x plus 1. Again, I have to be greater than -1. Can it include -1 this time? If I put -1 in, I get -1 plus 1 is 0, and the square root of 0 is 0. That would be undefined. So it can't be -1. It has to be greater than -1. So the domain here would not include -1, and then going to infinity. G of x times g of x would be the square root of x plus 1 times the square root of x plus 1. That would be the square root of x plus 1 squared. There's 2 of them. Are there any problemed areas here? Not like this, where you were going to be undefined in the domain with a 0 in the domain. So this one would still be true, that the domain would include -1 to infinity. Composition of functions. How do we say this right here? That is f of g. That little circle, that's how we say it, f of g. That means that we want to take g and we want to put it into f of x. F is the main function and g is the one that's going into f. This is what it looks like. Here's f, the main function, and we're substituting in g of x. So we're substituting one function into another. If I have x and I have my g of x, what am I going to do with my g of x? I'm going to substitute it into f. That would be f of g. Example 2, we have f of x and g of x. We need to find f of g of x and g of f of x. So let's start with f of g of x. That means we start with f. Here's my f. And wherever the variable is, that's where I'm substituting into. So that would be e. We're substitute in g of x. So g of x is the square root of x. And then we have g of f of x. So we start with g this time, which is the square root of x. And this time we're going to substitute in f of x. So we're starting with g of x, and now we're substituting in f of x. So we have the square root of f of x is e to the x. Verify numerically that the functions are not the same. Let's just choose the number 1. Let's say when x is 1. When x equals 1, I would have e to the square root of 1. The square root of 1 is 1. So I'd have e to the 1 power. Down here, if I did the square root of e to the 1, I have the square root of e. Whoops. Well, I can check and see if these are the same or not. I mean, clearly e is not the same thing as the square root of e. You could check that on your calculator. Here is the e button. Right here in blue, it's above ln. Those are reciprocals, opposites of each other, ln and e to the x. Then you have log and 10 to the x. These are also inverses of each other, which we'll be getting to. But here is your e to the x. So e to the 1, 2.72. So we get 2.72. Now if I do the square root of e, square root of e, and that does have a 1 still there for an exponent. So we say e, the square root of, we're going to do the square root of e, and that would be to the 1 power, equals 1.65. So numerically, we can see that those are not the same. Let's see. Finding the domain of a composition. F of x is x squared minus 1. G of x is the square root of x. Find the domain of the composition. Okay. A is g of f. G is the square root of x. Square root of x, but where there's an x, I need to fill in f of x. And here is f of x, x squared minus 1. And then for b, that would be f of g. So I start with the f function, which is x squared. So I'm going to put parentheses for the x squared minus 1. And now for the x, I'm going to substitute in g. G is the square root of x. And we are looking for the domain. All right. Well, if I was to look at this function on the calculator, we have the square root of x squared minus 1. Make sure your stat plot is off. And zoom 6 for a standard window, what we can see here is that the function is coming down and there's something that's going on in between here. So let's take a look at the algebra. We can see that it's a square root, so we know that we got to set it, whatever's under the radicand, we need to set that greater than or equal to 0 and solve. So we get x squared is greater than or equal to 1. So when we solve for x squared, we square root both sides and we get plus or minus 1. So x is greater than or equal to. All right. Now remember, when we're setting up an inequality, let's see, what did the picture look like? The picture, -1 and 1, the function was coming in. And we can see that there was nothing going on in between -1 and 1. What is the domain then? The domain would be from -infinity to -1, goes all the way to -1. That includes -1. And then you have to say in union with. We're talking about two different pieces. So in union with, that's the first piece. We're going from 1 to infinity. That would be the domain. Okay, let's look at B, the square root of x squared minus 1. All right, so we see here that when we set this, whatever's under the radicand, greater than or equal to 0, it's already solved for us. We know that the function is going to have to be greater than or equal to 0. Let's take a look at the function. We have the square root. And there you go. You can see that it has to be greater than 0. Notice that a square undoes a square root. These undo each other. So really we're looking at x minus 1. And that is a linear function, but the conditions still have to apply from the first part. This line would go to infinity. But this one, notice how the y-intercept is -1 and the slope is 1, but you have to be greater than 0 still. The domain for this one would be that you're going to have to be from 0 to infinity. This picture started at -1. Decomposing functions. For each function h, find functions f and g such that h of x equals f of g of x. So if I want to find h of x, first I've got to find f of g of x. Example 4, decomposing functions. We are going to be working backwards. For each function h, find functions f and g such that h of x equals f of g of x. Okay. What do we see here? We see that x plus 1 was substituted in to the main function. So x plus 1 would be g of x. We got g of x equals x plus 1. And then f of x, would be, this would be an x, so x squared minus 3x plus 4. So if I took x plus 1 and substituted in for x, it would be x plus 1 squared minus 3 times x plus 1 and then plus 4. That's decomposing. You're working backwards. For problem B, we can see that this was substituted in for an x. So I would say that g of x equals x cubed plus 1. And then f of x was the square root of x. So g is going into f. X cubed plus 1 is going in for this x. Example 5, modeling a function composition. In the medical procedure known as angioplasty, doctors insert a catheter into a heart vein through a large peripheral vein and inflate a small spherical balloon on the tip of the catheter. Suppose the balloon is inflated at a constant rate of 44 cubic millimeters per second. A, find the volume after t seconds. Suppose the balloon is inflated at a constant rate of 44 cubic millimeters. So the volume would be 44T. When the volume is V, what is the radius R? All right, so volume equals 4/3 pi R cubed, 3 dimensions, spherical, and then we're solving for R. So I am going to divide by pi. No, let's get rid of this first. So I am going to use the reciprocal and multiply by 3/4. So we have 3/4 V equals pi R cubed. We could divide by pi. And we have R cubed equals, let's see, if I do 3/4 V divided by pi, I know that when I'm dividing, I need to flip and multiply. So I'm going to make this a fraction and then flip and multiply. So that would be 3/4 B times 1/pi. So that would be 3 times B times 1 and 4 times P. So that'd be 3V over 4 pi. And then the last thing to do would be to undo the cubic. So that would be the cube root. Cube root of 3, cube root. We get R equals the cube root of 3V over 4 pi. Write an equation that gives the radius as a function of time. What is the radius after 5 seconds? Okay, so we are going to substitute in what the volume is. That's 44T. 3 times 44. Divided by 4 pi equals R. All right, here we go. We have math. Number 4 is the cube root of parentheses 3 times 44 times 5, and I'm going to close that parentheses, so I'm putting parentheses here to keep it grouped together and here to keep them grouped together. And then divided by, open parentheses, 4 times pi, close my parentheses and get out from underneath the radicand, and we have 3 point, so we have radius will be 3.74 millimeters after 5 seconds. Verifying pairs of relations. Okay, we have which ordered pairs are part of the relation. So 2, -5, that would be 2 squared times -5 plus -5 squared. Does that equal 5? And 3 would be 1 squared times y plus y squared. Does that equal 5? And 2, 1. So x squared times y plus y squared, does that equal 5? When you do your number crunching, we get 4 times -5 is -20. And then -5 times -5 is 25. That equals 5. We get 1 squared is 1 times 3 is 3 plus 9, and that does not equal 5. We get 2 squared is 4 times 1 is 4 plus 1, and that equals 5. So 2, -5, therefore, and 2, 1 are in the relation. Using implicitly defined functions, describe the graph of the relation. All right. If we look at the left-hand side of the equation, we see that we can factor this. X times x is x squared, y times y is y squared. I need a positive 2x. So that's a positive 1x. And this would be another positive xy. This would be another positive xy adding to 2xy. So positive sign. So we have x plus y, there's 2 of them, squared equals 1. I'm going to solve this to see what's going on. We have the square root, and then we have plus and minus the square root. X plus y equals plus and minus 1. So we have x plus y equals 1. We have x plus y equals -1. Y equals -x plus 1. Y equals -x minus 1. So it looks like we have parallel lines. This one is starting at +1, and then the slope is rise -1, run 1. Rise -1, run +1. And we have starting at -1, rise down 1, and over 1. So what we have here then are parallel lines. These are 2 parallel lines.